Graph the following absolute value function. G of x equals the absolute value of negative x squared plus 4x plus 5. State the domain and range. Here, the entire function is within the absolute value symbols. So in this case, we'll graph the function within the absolute value symbols and then reflect any portion of the graph that is below the x-axis, corresponding to negative y values, across the x-axis, making the y values positive. In this case, the function within the absolute value is a quadratic function. This means that we will convert it to vertex form by completing the square. Recall vertex form: y equals a times x minus p all squared plus q. Once we have it in vertex form, the vertex of the parabola is at the point p comma q. The a value indicates the direction of opening and also indicates the stretch factor for the parabola. We then have the y equals negative x squared plus 4x plus 5. Note this is the expression inside the absolute value symbols. In order to convert this into vertex form, we have to complete the square. To do that, we will first factor out the negative 1 that is beside the x squared term. We factor that out of the negative x squared and the plus 4x. This gives us y equals negative x squared minus 4x. We then have to add something such that we create a perfect square trinomial. Divide the negative 4 by 2 to get negative 2, and then square that negative 2 to get positive 4. Adding 4 then produces a perfect square. We then still have the plus 5 outside the brackets. Now when we added that plus 4 inside the brackets, we have to compensate for that. Note that the plus 4 inside the brackets is multiplied by the negative 1 that we had factored out outside the brackets. This means that we're actually subtracting 4. To compensate for that, outside the brackets, we have to add 4. We then have our function in vertex form, y equals negative x minus 2 all squared plus 9. This means that we have our vertex at p comma q, which is corresponding to the point 2 comma 9. We have an a value of negative 1. This means that the graph opens downwards and it is congruent to the graph of y equals x squared. Each additional point, we can go over 1 and down 1. As we go over 2, we go down 4. As we go over 3 from the vertex, we go down 9. And over 4 from the vertex, we would go down 16. We then have the graph of our parabola opening downwards. We now have to look at the graph of the absolute value of negative x squared plus 4x plus 5. Note here that any portion of the graph that is greater than or equal to 0, meaning above the x-axis or on the x-axis, will remain unchanged. The portions of the graph that are below the x-axis must get reflected across the x-axis such that the y values become positive. We then have the graph given in green. As for the domain and range, there are no restrictions on the possible x values, so the domain is XER. As for the range, the y values must be greater or equal to 0. So the range then will be y greater than or equal to 0, and it's all real numbers greater than or equal to 0.